So we're going to kind of start today the same way that we did on Friday, where I'm going to give you a situation and your job is to try to see if you can figure out the mystery part to what we need to use for our homework tonight. So I am not going to give you the objective yet. We'll get to it. But what I will give you is some directions. Oops. I'm going to ask you to graph each equation on the same axes. Then look for a conjecture. Regarding the lines you get. Now I'm being very, very, very vague. And I'm going to tell you this is going to be a little bit of a pain to graph, but so be it. These are your two equations. 2x minus 5y equals negative 3. And 5x plus 2y equals 6. And I'll go ahead and pass out graph paper if you don't have any. And because I think you need to graph and be as accurate as possible to try to see what's going on here. Jason. I'm sorry? The TAG. Conjecture. Conjecture. Okay. It seems that perhaps when some people graphed, they saw maybe the lines were for sure intersecting. I did have some issues with some people that didn't draw their lines long enough. You should always extend them, and if there's a possibility for them intersecting, you need to make sure that they intersect. And Chloe feels that perhaps they were actually perpendicular. Yeah. Okay, so my question, I don't want it answered, but I just want you thinking, is there something in their equations that would reveal that they would be perpendicular? So don't answer that question, just think about that question. So I'm going to go ahead and take each one of these and put them into slope-intercept form. And so I can graph more easily. Shh. Now what's a little weird on this one is I'm going to get a y-intercept that is a fraction. Two negatives make a positive slope of 2/5 x, and two negatives make a positive y-intercept of 3/5. Shh. The second equation, we have 5x plus 2y equals 6. Subtract 5x from both sides. We get 2y equals negative 5x plus 6. Divide everything by 2. And we get y equals negative 5 halves. That's not looking real good. Negative 5 halves x plus 3. So I'm going to bring in my graph paper. And let's see. Over here. That might be all that I need for this one. So I'm going to take the shape over here, and I'm going to graph the slope, or the y-intercept is 3/5. So that's going to be a little over a half, but not up to 1, so somewhere like that. And then I'm going to have to rise up 2, so I'm going to rise up in the same position that it was, and then run to the right 5. So that would be somewhere about there. And then I'm going to connect those with a line. And the other one, I'm going to take its slope and y-intercept. So it was 3 on the y-axis, and I rise down. Oh, I do need to put a few more in here, don't I? I'm going to rise down 5, 3, 4, and to the right 2. And without having a nice ruler to make sure my lines are exactly straight, and without having a protractor to measure, I'm going to have to kind of agree with Chloe. They do look awfully perpendicular. So was there something that you noticed, Anish, in your equations that you would say, hey, that's interesting. If my lines are perpendicular, bam, is true. Oh, somebody was just a little too busy talking with Tyler to actually answer a question. Amy, what did you notice?
Their slopes are the opposite of each other.
Okay, so we have, looks like perpendicular lines. And we notice that the slopes are opposite. Is that all they are? I had a slope of -5/2 and a slope of 2/5, so you're right, they're opposite signs. But is that all they are? Okay, Armand?
One's positive and one's negative.
That's what opposites mean.
Oh.
Yeah, it has to deal with signs only. Mia?
One is the reciprocal of the other.
Okay, and slopes are reciprocals. So what you guys, those of you who noticed those two things, you've just figured out what's unique about the slopes of perpendicular lines. They're opposite reciprocals. It was so much easier when we had parallel lines because they were the same slope, so that was easy. This one we're going to have to do a little bit of work with. So what we're going to do is write a couple notes with our objective, and then we'll do a couple practice problems. Okay? So you will not be graphing on your homework tonight. It'll be all algebraically calculated. So we'll go to the next page. So our objective today is to, 1, understand the properties of perpendicular lines. And I'm going to put a little symbol here. Is that upside down capital T? That's the mathematical symbol for perpendicular. And then 2, write equations of lines perpendicular to a given line. Now this is interesting. This is your lesson 7-8, the same one that you did on parallel lines. And I was looking through the online book, and I did not see mention anywhere in there perpendicular or parallel lines, though the high school does kind of mention this. So I don't know if that is a topic that's now going to get pushed to another time, but we're still covering it at this juncture. Okay. Hey, he's here.
I had to leave early.
Okay, so let's go ahead and first let me give you an actual definition. Let's see if somebody can actually give it to us of what are perpendicular lines. Because I'm going to go with what the geometry rule says, and so sometimes people like to tell me too much. Connor, what do you think?
Lines that intersect at a 90 degree.
You actually said too much. Okay? What do we call an angle that measures 90 degrees, Connor? And right angles all we're allowed to say. Okay? What we know about right angles is they measure 90 degrees. And see, this is kind of a preview. When you get into geometry class, you can only use the exact definition. If you add something to it, now you're adding a definition of something else into it. So we're going to say perpendicular lines are two lines that intersect to form right angles. Now, this is at least something different because on Friday all we had were lines that never intersected. So at least we have some intersection. But this one's intersecting in a very specific manner. Larkspur, you had your hand up. You have a question?
No, it's all good.
Okay. All right. So what we want to do is explore the notion of where we saw the big idea of happening for us to pay attention to was dealing with slopes of perpendicular lines. So first, they're opposites. So that deals strictly with sine only. But the second thing that you guys mention is they are reciprocals. Okay. So let me ask you this question. If I have, my two slopes were 2/5 and negative 5/2. Do they meet the definition of slopes of perpendicular lines? Are the signs opposites? One positive, one negative. Are they reciprocals of each other?
Yes.
Okay. So I'm going to ask you to do one more thing. If you multiply them together, what do you get? I heard some of the answers. Negative. Signs are different. You're going to get a negative, and you're going to get a -1. So we can add to slopes of perpendicular lines. They're opposites, they're reciprocals, and their product always equals -1. So that's a good test. Sometimes people get a little bit like about reciprocals. If you can multiply the two slopes and get -1, then yes, you have perpendicular lines. So if you remember Friday's homework, the first group of problems, you were given two equations and your job was to determine are they parallel. So you figured out what their slopes were and the slopes were identical, then the answer was yes. If the slopes weren't the same, even if it was just off by a sign, you said no. So tonight, you're going to get the same thing. You're going to get two equations, and your job is to look to see if their slopes are opposite reciprocals. Now, we used to call it for years negative reciprocals, but then a lot of kids always thought that the reciprocal had to have a negative in it. But what we were trying to say is that the sign would be different than what the other slope sign was. Okay? So that is going to be the easy piece. So to determine if two lines are perpendicular, perpendicular. No, hello. I gotta learn to spell perpendicular. There we go. You're going to solve each equation into slope-intercept form. And the whole reason why we do that, is the second step. So you can identify the slopes. And then you actually have two ways to test. If slopes are negative or opposite reciprocals, see, I mean, still coming out with the old words. The lines are perpendicular. Or if the product of the slopes equal -1, the lines are perpendicular. So that's 13 through 25. Just doing that. Armand.
Can I go to the bathroom? It's an emergency.
Okay, I guess, but you're going to miss out on notes. We're not done.
Is it just examples or
No, we're talking about other stuff.
they all work?
Are you sure?
Yeah.
Okay.
Actually, I'll go right now.
The next thing you're going to do is actually write equations, and you've got 4. You're going to actually do 27 through 30, and then 26 has a special question. So to write equations, of a line perpendicular to a given line, and that's going to be those last 4 questions and more what you're going to see on your test on Friday. So to write an equation of a line, I had to write my F weird because of something here, so you ended up looking like a P. There we go. Of a line perpendicular to a given line, you need to put the given line in slope-intercept form. Oh, in. And the whole reason why we put it into slope-intercept form is to identify its slope once we've identified its slope, we're going to take the opposite reciprocal of that slope, and that's going to be the slope for your line. So I'm going to mark it as, let's do this way. So when you see M perpendicular, that's the slope of the line that you're trying to write. That's perpendicular to the given line. Justin?
Can the y-intercepts be different?
Well, think about it, looking at the example you had. Could you get them to be the same?
Yes.
With the opposite slopes? I don't think it's possible. Okay. And then you're going to use the perpendicular slope with the given point in point slope form and solve. Now, I was asked, is it okay instead of doing point slope form, can I just go into slope intercept form, figure out the y-intercept, and then plug it back in? And the answer is absolutely you can do that. The strategy that you choose to use is yours. I'm just going to keep emphasizing point slope form because I think it's a super easy form to use. Okay? So your given is going to look something like this. You're going to have a line perpendicular to this equation, and I'm going to make this an easy problem. And you're also going to be given a point. Now, why would I say this is an easy example? Why is it easy? Larkspur?
It's already the slope-intercept form.
They already put it in slope-intercept form, so we just need to, for this first step, grab out identify the slope. So the slope for this particular one is 2. But that's not the slope we're interested in. The slope we're interested in is the opposite reciprocal of 2. What's the opposite reciprocal of 2? Opposite. Negative, and then 1/2. Now I'm going to use that negative 1/2 as the slope, and I'm going to use the point, and I get y minus the y value of 5 equals the slope, negative 1/2, times the quantity x minus the x value, which is 3. And then I just start solving. So first I'm going to distribute, and I get y minus 5 equals negative 1/2 x. Two negatives make a positive 3/2. Okay, then I'm going to take this over here where I have a little bit more room. Then I'm going to go ahead and add 5 to both sides, opposite operations. But what I notice is I can't actually add to the 3/2, so I need to change the 5, to the 3/2, so I need to change 5 into a fraction that has 2 in the denominator. What would be the fraction that has 2 in the denominator that has the same value as 5? Michael? What would the numerator be? Yeah, so we've got a positive 10 over here. So finishing up, we get y equals negative 1/2 x, and then 3/2 plus 10/2 is 13/2. So that's going to be what all of those problems in the book are going to be like. Armand.
How'd you get the negative 1/2 out of 2?
Okay, remember all perpendicular slopes, and we were told that our line is going to be perpendicular to this line, are going to be opposite in sign and reciprocals. So opposite of positive is negative, and opposite of 2, or the reciprocal of 2 is 1/2. Okay? Just no graphing on tonight's homework at all. Now, how would this problem change if they gave you 3 ordered pairs? And they said the first 2 come off of the line that yours is perpendicular to. Justin? Yeah, and actually it turns out it's not that bad, so I'll show you an example of it. So same scenario, same directions, write an equation, perpendicular, but this time it's going to be to the line passing through a couple points. So write equation of the line perpendicular to the line passing through the first 2 points. So this is a little confusing. I want you to understand the first 2 points represent a line that yours is perpendicular to. Okay? And passes through the third point. I know, so this is kind of confusing directions. So our 3 points, 1, 2, negative 3, 5, 4, 1. So these 2 form the line perpendicular to yours. So what we need to do is figure out what its slope is. Got a double negative, so we'll make that a positive. So we get negative 3 over 4. And then you are going to find the slope perpendicular to that. So your slope has got to be an opposite reciprocal. So what would it be? What would it be? It would be positive, opposite signs, and reciprocal 4/3. So I'm going to take this slope and this point, and then we're going to write an equation with the 2 of those. So y minus the y value of 1 is equal to the slope, which is the 4/3, times the quantity x minus the x value, which is 4. And then we just do the math. Y minus 1 equals distributing 4/3 x minus 16/3. Add 1 to both sides, but I can't add 1 to the fraction, so what fraction should I be turning the 1 into? Armand?
3/3.
3/3. And now he's a positive 3/3. So we get y equals 4/3 x. Negative 16 plus 3 is negative 13/3. And that's the equation. Okay?